Welcome to Innovators. Today's guest is Dr. Robert Moir, a researcher and technologist whose work bridges philosophy, mathematics, and advanced computation. With dual PhDs in philosophy and applied mathematics, Robert has spent over a decade tackling the challenges of scientific inference and complex systems. He's played a key role in designing protocols and building infrastructure for distributed AI ecosystems at Earth-64 and now HyperCycle. Robert's unique perspective, combining rigorous scientific reasoning with hands-on implementation, offers invaluable insights into how we understand, build, and scale the technology shaping our future. Let's get right to it. Robert, so nice to have you with me today. How are things where you are?
Things are great. It's a beautiful sunny day here in Vancouver.
Oh, beautiful part of the world. I lived in Northern California for a while, so I know what it is to be in that part of the world. It's actually quite pleasant this time of year. I wanted to start off with a bit of background about you. One of the things that I find very fascinating is that whole path through academia. And so you hold PhDs in both philosophy and applied mathematics. How did your dual background shape the way you approach these complex systems and the technologies that you are in today?
It's a good question. So I mean, there's any number of ways to answer that question. I think my approach to philosophy is really a sort of form of multi-perspectivalism, I guess. So capability or the discipline of it for me is looking at things from many different points of view as a way of better understanding the system or phenomenon or situation that you're engaged in. So my interest in philosophy have always been very multidisciplinary. So trying to understand commonality across disciplines, like common structural features and things like that. So crossing from philosophy into applied math is another kind of dimension of that in computer science. And so the more experience I kind of accumulate in different fields gives me greater ability to think about things from different points of view. So in terms of, entering into the technology startup world, different elements of that come out in different ways for me, I think. So, obviously the computer science background is highly relevant in the areas that I work in. Some aspects of the mathematics, there's the general skills you learn in science degrees about how to learn, factor into it. And as well as, I guess, for me, there's an element of a values focus that comes in for me that is, so there's some kind of training in that comes from my philosophy degree that was not my specialization, obviously. It was focused in, more philosophy of science and mathematics. But that's something I care a lot about. And so thinking about the role that values play in the technologies that we're building and what kind of, values that they support through their design is also something that comes into, it's not there at the forefront, at least not at the moment, but it is something that I think is a very important element to think about. And I think it's going to be more and more relevant as we go forward.
No, I like that. So I can relate to the fact that every experience that I have in my life today, in one way or another, is going to inform my next interaction, right? So my interaction with you today, whatever is learned and, we come from this, it will help inform my next iteration of relationship with you, or maybe another person that might be in a similar role in my life as you are playing, that type of thing. And so That I know that from this first response, I already have a word I'm going to need to go look up, right? And I love learning new things. So I'm intellectually curious, and I have a feeling I'm going to have that a few times more in this interview. So let me jump into my next question. Given what you just said, can you share a pivotal moment from your academic journey that influenced your transition from academia to industry, particularly in this tech startup world?
Yeah, I guess in terms of thinking of the transition, there's something reasonably close to a pivotal moment. I'm not sure I can sort of pinpoint it exactly, but it's essentially, as I mentioned before, my research interests in academic context are very highly multidisciplinary. And so at some point I realized that in order to get funding for my research program, I needed to specialize that into one, maybe two fields, as opposed to the broad multidisciplinary thing that I wanted to do. And so I followed that. I was exploring how to do that in the context of computer science. And I had, a nice little research project that made sense in that context. But as soon as I kind of converged on that, realizing what that would look like, my passion for the project kind of vanished at the same time. It's in the sense that, yeah, this is a solid way to go forward scientifically. Like I can see how that project would lead to genuine scientific insight. It would carry forward the research gains that I had made with my prior work. But it was such a rarefied form of what I really wanted to do. And then realizing it would be another 10 years of doing research along those lines before maybe I could start to get into, what my real sort of research passion was. I realized that, okay, no, I need to do something else. So I needed to rediscover what my passion could look like in a context outside of academia.
Interesting. And so maybe you can give me a short answer to this, and that is, so in academia, and you're taking on a project, you seek grants, or some way to support yourself, right? And so I'm thinking that into the context of the startup world, there are probably many similarities, right? A startup is trying to find investment to pursue its idea, innovation, what have you. And in academia, it's basically you're trying to fund yourself so that you can do your research and pay your bills and eat and clothe yourself. And I'm sure there's some similarities in that. Do you find that to be true?
Yeah, I guess so. It depends on the discipline. Like, so some disciplines are funded differently. Like, so there's less of a pressure for the individual professors to have research grants. At least in my experience in the context of philosophy, that was the case. So there were some professors that did have, independent research grants, and that expanded the capabilities of what they could do. But there was funding sort of just integrated into the departmental funding framework. Whereas on the science side, it is more like that. So each individual professor is responsible for funding not only their own, it is their research program, but they might have a whole lab full of graduate students and postdocs that they also, the research funds need to support. So in that regard, it's a little bit like a startup in the sense that, you, in order to carry that forward, you have to, ensure that there's sufficient funding to pay for all of the human resources that are going into what you're trying to build. But the focus is very, very different in terms of what it is the activity is and what the outcomes are. Right. And the motivations of the people involved are very, very different in the academic context.
Sure. Yeah, I had never really put much thought to that element of it. Thank you for at least elucidating a bit of that for me. I wanted to jump into now, because you had a really rich academic career prior to getting into the startup world. How does your understanding of scientific reasoning, particularly how theories are built and tested, inform your approach to designing and implementing these complex systems with companies like Earth 64 and now HyperCycle?
So I guess I would say to that, so from my perspective, the way that I've explored theory development and theory application in the context of science, it's a very rich and dynamic process. It's and with a high degree of variability, like across time and space. But one of the pieces, I guess, that comes to mind with that is, so this is, again, will be full of bias from my limited experience, because I'm not an historian, but I did a little bit of work probing into theory development in the context of, electromagnetic theory and some other areas. And part of what you see there is there are different phases of it. So like you inherit some kind of theoretical content from whatever previous scientists have done in a given area of research. And then depending on, what your role is, what your capacities are, what area you're working in, it could look very different, but I'm talking about the sort of broader pattern. So I'll try and carve out a piece of that.
Okay.
So the key piece, like one of the interesting insights from, what the theory building process looks like, say, right, in science. It starts with really a deep understanding of the phenomenon that you're trying to investigate. So you don't start with a detailed theory. Like you start with, you need to understand the phenomenon that you're trying to build a theory for. So that's a whole different kind of skill set and a very painstaking endeavor of experimental work and or observation, depending on what phenomenon you're looking at, gathering data, analyzing that, modeling, making sense of that. And after a long time of building up a clearer picture of the structural relationships and how you can describe those efficiently, so such that when you I think this is going to happen if I do this, and then you go and do it, and that actually happens. So you start to see that you're understanding how this works. It's only after that has matured a long way that you can bring a theoretical formal framework into it, like a scientific theory, to actually formalize those relationships and then be able to use the mathematics to do those same kinds of investigations that you would have been doing practically in the lab. So if that picture kind of makes sense, there's a little bit of that same kind of flavor in the context of, in which I've been working in. Anywhere where you have, sort of some kind of theoretical framework you're bringing and some kind of complex phenomenon that you need to, interface with, you'll have similar kinds of dynamics, but lots of differences as well. In this case, I guess I can see a little bit of similarity to, so for me, I came into Earth 64, which is a data structure, with the basic framework of what that data structure is already specified. Okay. So this was Tufi's idea coming out of prior projects that he had worked on. But in order to realize that, so this is kind of taking an idea from concept to implementation. So how do you implement this in terms of actual detailed specified data structure and protocols that allow the processes to happen, and then implementing those? It's a complex dynamic of understanding the kind of phenomenon that emerges from those choices that you make in specifying the details. Does that make sense? In the implementation process, there's sort of layers of implementation that you have to go through. And then eventually you sort of understand how that works in that context. And there's a feedback to, okay, so is this the right specification that I came up with initially, given now my understanding and detail of how this works? Like, okay, no, maybe I need to change that a little bit. same idea in science. Like, so you have an initial hypothesis or model, and then you test that experimentally or observationally, and there's some error, and like, okay, maybe I need to adapt this picture a little bit, and there's a learning process, and that it's that feedback between, in this context, sort of theory and experiment or observation in science, or here between sort of formalism or specification and implementation. There's a similar kind of dynamic involved, and a real need to be flexible and adapt your ideas and concepts as you go in order to hone in on something that actually works effectively for what it is you're trying to design. But in the what's different in the startup context, and among other things, is you're trying to build a product that people will find useful, and so you have a market to appeal to.
Yeah.
Not just a sort of great broader community of scientists that you need to communicate, your scientific insights to.
No, I like that.
Yeah.
You once said, and let me make sure I get this right. You once said that the real complexity of a system often reveals itself during implementation. Can you give me an example from your work where initial frameworks had to be significantly adapted to respond to the practical challenges of the day?
Yeah. Well, I think Earth-64 offers another example of that. Because the initial work that I did on that project with Dan Tolliver and Jessica Radley, so we had lots of long conversations and worked together to build an initial sort of tight specification of what the data structure could look like, to meet the broad set of requirements that we'd outlined and under Tufi's guidance, like what were desired in terms of what this thing should be able to do. So the result of a long process was this sort of tight spec of what the data structure would look like. And then you started, building some early implementations of that and sort of seeing how things need to be adjusted along the lines of what I'm talking about. But then at a certain point down the road, we realized that, so partly this little piece we built was really not the whole thing. I mean, we knew that it wasn't the whole thing, but in the sense that there's more that really needs to be factored into how this piece is going to be designed, given the larger picture that this needs to link into and all the other pieces that need to be built out. And realizing, sorry, go ahead.
Well, it was just so the when you dive a little deeper into this particular segment of a project and new insights are found, those new insights will inform the next part of that the next segment of that project that you're going to put together. Now a lot of this starting to make sense to me, how you were saying we need to be flexible when we're building these really new and dynamic systems, because what we do today may uncover or unfold something that we had not previously seen. Therefore, how can you plan for this unknown if you don't know it's there, right? And so these insights create new insights that create new directions that create new insights and new directions. Okay. It's all becoming a lot clearer to me now. Thank you very much.
Yeah. Okay. Good.
Carry on, sir.
Oh, well, so the point I was just trying to get to is the other part of it that we realized is the Earth-64 as a data structure is really this very generic thing that could be imagined in a number of different ways. So in order to be faithful to that, we didn't want to assume that this particular way that we've interpreted how it could work is forced to be the only way it could work.
Right.
Because, and part of the reason for that is we wanted to leave the door open to the possibility that sort of some decisions that we think make sense could channel this tech along a particular direction, that is incompatible with other things that people might want to do with it in the future. So we didn't want to cut off those paths entirely, but we also wanted to try and make, a canonical version of this that is going to be the one that people use, because that has interoperability benefits and various sort of, I can't think of the right way of describing it. But as you build up additional support tools around this thing, it becomes more usable. And if you start again from scratch, you don't have the benefit of all these things that build around it. So it's beneficial if there's some stability. But so realizing all those different aspects totally reshaped how we thought about how this data structure needed to be defined and structured, and it became a much broader thing, much more flexible, while still allowing us to do what we wanted to do, and not interfere with other possibilities of how this could be done in the future.
Sure.
So we came up with I think a nice way of harmonizing all of those different concerns, but a very dramatic shift from the initial form of the specification that we had.
Right. And the applications, there could be applications that rely upon that base level technology that none of us have even thought of yet.
Yeah, absolutely.
You know what I mean? And I guess that's the hope, right? When you are innovating, the hope is that somebody will take it and do something incredible that you never even foresaw. That would be where I'd be coming from anyway.
Earth-64 as a data structure is a very generic thing, and so this was part of the difficulty of explaining what it could do, because it could do so many different things.
Sure.
But the more you hone in a particular use case, the more you want it to behave in a certain very specific way. So you want to be able to sort of channel it to best meet that use case, while not cutting off the ability of some other super cool thing that you might want it to be able to do that's very different and maybe a bit incompatible. So that's the kind of flexibility that we wanted to provide.
No, I get that. Thank you. I want to shift a little bit. I want to dive into some AI stuff a little bit. I want to open up that door and that topic. AI inference and distributed intelligence. So as your focus shifted towards AI inference, as you got into HyperCycle, what unique challenges and opportunities did you see in this space?
Oof. I mean, it's a wide open space. There are lots of different challenges and very massive opportunities, I think, in this space. And there's a whole bunch of different directions we could probably go with this. So I'll pick one that comes to mind. So if you think about what HyperCycle is set out to do and set up to do, it's the idea is, allowing AI models, engines, agents, services to connect and transact with each other peer-to-peer without intermediaries. And there are interesting things that could be done in terms of training AI as opposed to just inference. So I'm assuming you mean AI inference in that sense. There's the sense of scientific inference that, from my background, where both training and AI inference are forms of inference. But I'm assuming that's not what you mean. But I could view it in those terms. But one thing I suspect will happen, and I'm not an AI scientist, but that there'll start to be a blurring of these things more and more in the future, as the capabilities for intelligence sharing and learning change in this more sort of decentralized context. But I'll just leave that as a speculation, intuitive speculation on my part, not coming from a scientific standpoint.
All right, audience, do not write that in stone.
Yeah. So part of what's really interesting about this is, if you think about it, like AI agents have a telephone and they can call any other AI agent they want in the world. And that's just the baseline. And if you start to think of AI agents a little bit like websites were in the 1990s, everyone's going to have an AI agent that can, handle things on their behalf. And companies will have them. AI agents may even have AI agents that represent them. If they're sort of highly capable, sophisticated things, they may have less capable agents that are talking to other things and then gathering information and reporting back. The sky's the limit in terms of the possibilities here. Mm-hmm. There are deep technical problems in terms of how you deal with, interoperability across systems, but that's, a big part of what HyperCycle is providing the interconnectivity layer for, at least from the point of view of inference. Training is a different story, and there's deep scientific problems there that people are currently researching. If the challenge really is, we take it from the point of view of how we get these things to connect with each other, that's the challenge that HyperCycle is meeting. And in terms of opportunities, there's another challenge, I guess, is how are these interactions going to work when the agents don't have a script or a structure according to which, they're not coordinated according to some, algorithm or a set of instructions, like global set of instructions about who the participants are and what their relationships can be, but it's this open thing. How do we navigate that? That's a wide open problem, I think.
Interesting.
But in terms of creative opportunities and shared intelligence, the possibilities are both sort of daunting and a little bit concerning or frightening, depending on where that what territory you explore in that direction, but also like extraordinarily positive in terms of potential for beneficial outcomes. And I think so. Maybe this is another place to bring in the values point, because if you think about any product of human endeavor is imbued with values, whether we recognize it or not. Correct. We end up sort of just by our nature imbuing whatever it is that we create or interact with the values that we hold. So, structures in society tend to reflect the values of those who are responsible for putting those structures in place, and so on. In this case, we have this totally new, if you think about how transformative the internet has been for society and for, global economy, this is a whole new internet that is just getting started. This internet of AI agents that can all interact with each other. And so there's huge gains to be made in terms of learning and understanding. So sort of scientific work in all areas. So not just natural and what's the life sciences, but also social sciences and humanities. Huge opportunities for really important, I think, understanding, development of understanding of who we are and how we can live better, in the sense, better is not a very good word, but it needs to be defined. But in the sense of, I'm getting a bit sidetracked. I'll hone back in. What I was trying to bring in with the values piece is there's an opportunity here, I think, for people, if we do our job well, and there's sort of opportunities to design aspects of systems to allow all the various stakeholders to have their values be expressed in their interactions with the system, then we end up with a I don't know what the right, I'll just call it a global network. I don't know what to call it. That is a reflection of the values of the humans on the planet that are, putting their energy into creating it and receiving, the benefit out from it. And an opportunity, I think, to look for new ways of solving problems, that creative solutions that are to mutual benefit, rather than this old world notion of, one person has to win and the other loses. So that, I think, is both a challenge and an opportunity. Like I think because of how greenfield this is in many ways, there are opportunities to build systems that way, but it's a massive challenge to figure out how to do that and to get people to support technologies that provide that kind of capability. But I think this is, I guess, a hypothesis, one of the ways that we help to ensure that the systems that we build really are beneficial to humanity is if there's a way for everyone who's involved in participating in it has a way of genuinely, meaningfully expressing the values that they hold in terms of how that system behaves and functions.
Agreed. I'm in complete agreement. And one of the core kind of like values that have aligned the two of us. I wanted to ask another question that I thought really tied into this, kind of under the practical applications and future directions type of topic. Let me see if I can formulate it in my head real quick. Okay, so at Earth 64 and HyperCycle, you've been in there mixing it up with these protocol designs and system development. What are some of the most exciting and ambitious projects that you've personally got to be involved in? Like elements of Earth 64 or elements of HyperCycle that have just like really turned on your passion pump, you know what I mean? And given you like a reason to wake up in the morning and just give it all you got.
So there's definitely been lots of moments like that. I'm not sure. I'm just trying to think how to answer this. I mean, I think the way that I work from the point of view of feeling like really excited about what we're building, and I'm sure you'll see the theme here because it has a values component to it. It's where I feel that we're building something that really will help to make people's lives better and have a meaningful impact on the human level experience, which is a bit weird for a technology like HyperCycle, which is intended to allow AI to talk to AI. It's not really about the human in the loop. And the human's not always in that loop. But when we're talking about these sort of the scale of these technologies and how transformative they can be, we need to look for ways that we're and ensure genuinely that we are creating technologies that are beneficial for humanity. I mean, I think we as a company are very aligned on that and looking for win-win outcomes, So in terms of projects that I think are an expression of that, the one that is closest to mind would be HyperY. Yeah. So where we're working with the World YMCA and the YMCA global movement through the I think it's over 13,000 YMCAs So that we would like to,
plus, yeah.
or 12,000,
Yeah.
that we'd like to get involved in this project, and not because, fundamentally, well, I'll speak from my own perspective.
Yeah.
That I think that this could be, there are real opportunities here to build an expression of this technology. So what's the technology? You could think of it as like a browser for the Internet of AI, as what HyperY provides, but with a specific flavor for YMCA users that allows them to share knowledge and share capabilities, and eventually to be able to bring people together, like physically bring them together. It for example, and again, this is like when you're dealing with really greenfield technologies, imagination plays a really important role in determining what you build, because you need to have the vision to build the thing.
Yeah.
And so here, I think part of what it could do is to recognize, oh yeah, so the agent you're working with knows a whole bunch of people that are experts in the area that you're, and can bring you together and find ways of people in your local organization. Yeah, so you guys should meet and talk to each other, and then so there's opportunities for this kind of thing where you're building systems that really support building and evolving human relationships, and the kind of real life on the ground outcomes that are beneficial to people and improve people's lives, as well as having an economic focus that providing meaningful work for people. I mean, that's one of the core pillars of the global movement for YMCA.
Yeah.
So there's lots of really powerfully beneficial work that can be done if you're building a system that's designed to be a support to people and to outcomes that make everybody's lives better. So that kind of thing really excites me. I mean, it's anybody's guess exactly how this will shape out. It's up to the Ys to decide what works best for them. But I do think there's alignment on that if we can, we want to have systems that have these capabilities, and I'm excited about that potentiality. And then that becomes an example of what's possible, and other systems can come along in different areas with different focuses, but that share that capability of having a profound impact at the human level.
Sure. One of the things that I thought was at least most fascinated me when I learned about HyperY was that, yes, Global YMCA is a global organization. However, of those 12,000 plus offices, territories, entities, they're federated in that YMCA Brussels may build an application in HyperY that is not necessarily adopted by YMCA France, Paris. You know what I mean?
Exactly.
And that the dynamic nature of that organization lends itself to a tremendous amount of autonomy. However, and also an interconnectivity element of it. And it's so, to me, that's really fascinating, because I think of very large global networky type systems of the past. I'm thinking about Instagram or Facebook or X for that matter. That platform is the same platform in Paris as it is in Brussels or Costa Rica. Right. You know what I mean?
Yes, yes.
The dynamic nature of the HyperY application and HyperCycle, and its ability that its nodes can literally operate any AIM in the registry, or any AI model, any AI module, any AI agent. HyperCycle tends to call them AIMs. So all of these agents, these AIMs, can be operated by 1,200 different offices at doing different things at different times, but all within the context of like the global brain. to me that is just, it's just mind-boggling. And I'm really, really looking forward to see how it matures, the maturation process of this revolutionary technology, because it's no longer a white paper. It has leaped out into the world. Hello, world, here we are. And people are building things in different places, or, you know, to serve their purposes, which is what people should do with tools, right? People use tools. Just, you know, in the old days, we used tools to agriculture, you know, to do agriculture and get food or hunt. Now we're using these incredible technological tools to solve our problems. Like I've fallen in love with these applications like Perplexity and ChatGPT and the Gronks and all these things, because they make me finding information that can be useful to me a lot easier than the countless hours I used to spend scouring the web and trying to differentiate reality from weirdness. Now, I'm not saying AI is void of weirdness. Sometimes there can be weirdness, and you only can get out of it what has been put into it, per se. But it really has been exciting for me. And if it's exciting for me on that, like, and I'm a Luddite, I can just imagine the other innovators in the world who are taking these tools and crafting very useful things from them. So I want to quote Robert Moir: "We are living in exciting times." It truly is. And so with that, I want to close with a last question for you. And it pertains to if you could have a dinner conversation with an innovator, past or present, who would that be and why? Like somebody who did some really innovative thing, and whether they're alive today or if they're from the past.
Right. Yeah. The only person I can think of right now that kind of fits to me, I guess, is Nikola Tesla.
Ooh.
And I think there's a whole host of reasons why, I mean, a dinner conversation wouldn't be nearly long enough for his, you know, brilliance and depth. And I think he was a, you know, creative genius on both the scientific and the engineering fronts, and in as an inventor. And just would love to hear him talk probably on any topic he was interested in discussing. But I feel like he also had a very interesting spiritual perspective, and he seems almost otherworldly as a being. So I think it would just be a remarkable experience to, you know, get his perspective on what's happening now on many levels of existence, and how best to respond to the needs of the time. Yeah, I guess that's what comes to mind.
I like it. I'll tell you what, the way things are going, I think within a short period of time, you'll have access to a digital twin of Nicola Tesla, right, and be able to have that holographic sit-down conversation for as long as you want. I think that's coming. I think the world of sci-fi is becoming the world of reality, and I'm just tickled pink that I've got a front row seat at it.
Totally.
You know what I mean? Yeah. All right, Robert, thank you so much for your time. Folks, thank you for tuning in. Remember to subscribe, press your like. We want your comments. If there's somebody innovating out there in the world that I have not come across yet, please let me know who they are. I would love to reach out. I'm trying to find incredible people who have incredible stories, because innovation in it by itself is an empty word until you get the story of the person who does the innovation. All right. With that being said, everybody, from Costa Rica and Vancouver, pura vida. So that was the show for today, folks. Thank you so much for tuning in. And like always, we'd like to encourage you to not only like, but subscribe to the channel for future content. See you next time.